Hey everybody, this is Unit 7, Video 1. We're going to review the triangle inequality theorem and then discuss different formulas used to find the area of a triangle. So the first question we're going to ask here is, how do you know if three sides can actually form a triangle? Below here I've got three different side segment measures for four different examples, and I'm determining whether or not if you put those together, would they be able to form a triangle? Imagine if I put three sides together, but they didn't close to actually form a triangle. This is a situation that we will have. So I'm going to start with a review of the triangle inequality theorem that you learned in your geometry class. The triangle inequality theorem states that the sum of any two sides of a triangle will be greater than the third. So we're going to test that with these examples. So I'm going to go ahead and pair up all the different possibilities I have here. I'm going to add 3 plus 2, 2 plus 5, and 3 plus 5. Now, according to the triangle inequality theorem, that these two sides I've chosen in all situations must be greater than the third side. 3 plus 2 greater than 5. Oh, that doesn't work. 2 plus 5 greater than 3, and 3 plus 5 is greater than 2. So because we have a situation where one of the sums does not greater than the third side of the triangle, there is no such triangle. Let's take a look at example number 2. I'm going to write down all three possibilities. And I have to determine whether or not all three of these situations are true. 15 plus 10, or 10 plus 15 is greater than 24, 10 plus 24 is greater than 15, and 15 plus 24 is greater than 10. So in this situation, a triangle exists. Take a look at numbers 3 and 4 on your own and determine whether or not these triangles exist. If the triangle does not exist, write no such triangle. If it does, write that the triangle exists. Your work is shown by these inequalities. Alright, next up is the area of a triangle. The first formula you probably learned in elementary school for the area of a triangle is area equals 1/2 base times height, or the area equals base times height divided by 2. They're the same formula, just written differently. This can only be applied if we have a height perpendicular to a base. So in this case, I would have to have the altitude dropped perpendicular to the base. If I have that, I can use this formula. Sometimes in an example like the first one here, we may not be given the exact height or the base, but perhaps I was given a value over here, which we could use the Pythagorean theorem to find the missing height, and therefore we could find the area of the triangle based on this formula. In my next example, what if I'm given two sides and an angle between them, but they're not perpendicular sides, nor is this a right triangle, so I could not use the Pythagorean theorem to find the missing side. Please note, angle B is not a right angle. Alright, so I'm given here, and this is important that you remember that the side opposite angle B is called little b, and the side opposite angle A, little a, the side opposite angle C is little c. There's no rule here that says that any of these angles is a right angle, so I'm going to mix up these letters as we move around the triangles. You're going to have to be comfortable with A, B, and C being in any position and know which side is across from which angle. So, if I'm given a situation where I have two sides given to me and the angle that falls between them, then I'm going to have to use a different formula. This formula is written in different ways depending on which sides and angles I'm given. I'm going to write down all three, but they're really just a manipulation of the same formula. The formulas are: the area will equal 1/2 little a times little b times the sine of angle C. What if I'm not given those particular sides? Area will equal 1/2 little b times little c times the sine of angle A. Or the area will equal 1/2 A times C times the sine of angle B. Notice that whichever side is not given, that's the angle that you want to use in your situation here. So if I have for this one, I have little c equals 3, little b equals 10, and angle A equals 64 degrees. So I can identify which of these three formulas that I want to use. I want to use, in this case, the second one. So I will have the area to equal 1/2 3 times 10 times the sine of 64 degrees. Be sure when you go to calculate this that your calculator is in degree mode, since we are using degrees for our angle measure. You'll simply just type that all in carefully. If you want to use 0.5 for the 1/2, of course that will work. So I'm going to calculate this. 0.5 times 3 times 10 times the sine of 64 degrees. Let's say we want to round to 2 decimal places, unless otherwise told. So for this answer, I would say that the area of my triangle, that subscript says area of the triangle, equals 13.48. Units squared. If I told you these were all measured in inches, it would be inches squared. All right, well, what if no angle measures are given, but I am given 3 sides of my triangles? There's another formula that we can use to find the area of this triangle. This formula is called Heron's formula. Heron's formula requires 2 parts. The first thing we're going to do is find the semi-perimeter. The semi-perimeter is the perimeter divided by 2. So I'm going to take, this is how we'll calculate it, 1/2 times all 3 sides added together. So in this case, I haven't really labeled my triangle, so A, B, C would make this A, this 7 is a B, and over here my 10 is the C. So if I'm finding my semi-perimeter for this particular problem, S will equal 1/2 times 7 plus 5 plus 10. The order of those doesn't matter. So my semi-perimeter is 11. The second step is to actually apply Heron's formula. Heron's formula says the area of the triangle with these 3 side lengths is S times S minus A, S minus B, and S minus C. So I have to know what my semi-perimeter is in order to use this formula. So if I were to substitute all of this in, my area of my triangle would be the square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. Be very careful when entering that in the calculator. In fact, it might be easier to find out the number underneath the radical before you go ahead and take the square root. So give you a second here and calculate the area of the triangle using Heron's formula. I came up with approximately 16.25 if I were rounding to the nearest hundredth, units squared. Okay, just to recap what we did here. First, how do we determine if 3 segments can form a triangle? Here we're looking to use the triangle inequality theorem. The second thing we did was to decide which formula we're going to use for the triangle or the area of a triangle. If we have 2 dimensions that are perpendicular to each other, then we can use area equals 1/2 base times height. This would be extremely easy to use in a right triangle or any triangle in which an altitude and the base are given. If 2 adjacent sides and the angle between them are given, then we will use the formula area equals 1/2 AB sine of C, or any of its equivalents, where we would replace the different side lengths. And if we're given 3 sides, we're going to use the semi-perimeter, which is 1/2 A plus B plus C, and then Huron's formula, which is S times S minus A, S minus B, and S minus C. For all of these, I'm looking for us to approximate to 2 decimal places unless otherwise stated.